We just take a look on what we mean by quantitative data analysis. And in the coming lecture, we will go in details about quantitative and qualitative. Actually, we have a chapter on quantitative data analysis, hypothesis testing. In terms, you have hypothesis. And I'm not sure if we should go in, through the hypothesis testing because a lot of things, there are a lot of subjects related to hypothesis testing. So I'm not sure if we can cover it in detail or maybe take another topic that may be
useful
for you.
Yes, we have studied that in details in statistics.
You study about hypothesis testing?
Yes, hypothesis, yes.
That's good. So maybe you just have a look on that chapter.
Maybe another topic.
I think so.
Would be good.
Because there are a lot, because there is a lot of, maybe they will study it in statistics.
They will not be studied in dashboard.
Because there are a lot of things that I want you to understand, to learn. For example, how to read from the literature. This is very important.
Yes.
How to write.
Summarize.
How to summarize.
How to write also.
How to summarize?
How to summarize, it's not easy to teach you how to do it, maybe some guidelines, but believe me, this thing you will learn from the experience more than from the lectures. From the experience, and the experience will be enhanced as much as you read.
From reading.
Because I've seen people are writing the name of the subject and then doing some brief description about it. I'm not convinced this is the correct way that we should go. I mean, it should go in line with our purpose, with our study.
It is skills, and these skills cannot be taught. I mean, I cannot teach you how to do these skills. I can tell you what's the skill, but I cannot be sure that you will do it unless you try to do it, unless you try to make like it. And this is, as much as you read, then you can do it, you can write. Try to choose a model. In your topic, try to see who is the best one who is publishing papers in this topic. This is very important, and make him as a model for you. Then just follow the best one. Don't choose the easiest one, the best one. And just follow.
So how will you know the best one?
As long as you read. As long as you read.
No scale, maybe follow some standards.
Citations. Yes. This is one way. Who is the person who is more cited? When you read, this is the first paper you read. Okay. They cite this person. The second paper, they cite this person. Third, they cite this person.
Google scholarship.
Yes.
Google scholarship.
You can search by. These are the skills of literature. How to cut the time. It's very difficult to deal with the literature in very traditional way or very straightforward way because you will lose your time.
But maybe citation people
You should to be selective. You know which one you should read, which one is more related, or which one is not related. Experience. So I'll try to see what are the topics that is more important than hypothesis testing, because hypothesis testing is more about statistics. Okay, let's go for the quantitative data analysis. Getting the data ready for analysis. After you collect your data, and you are ready now to key in the system and start analyzing. So you will do first the data coding. What do we mean by coding? transform the data from one form to another form, which is readable and understandable by the computer. Assigning a number to the participant's response so they can be entered into a database. So computer database only understand, okay, some kind of format for the data to deal with it. Okay? So we need to change the respondent's response or the participant response into this number or maybe this letter. Data entry after responses have been coded, they can be entered into database. So we code it first and then we enter to the database. Raw data can be entered through any software program, for example, SPSS. This is just an example. Okay? This is easy, straightforward. If you reach this step in your study, then you most likely achieved 70% of your research. Because the rest is how to analyze and interpret. Most of your time will be consumed in selecting the problem or getting the gap. This is the most difficult thing. And then the rest of things is easy. And the second thing that is, difficult after getting the problem is the analysis and interpretation of the data. Getting the feel of the data. Why? Why this number? Why should it be more than that number? Why should it be less? So try to be critical. Try to ask a lot of questions to yourself. Don't say, I don't have time, so I will just accept it and write something and that's it. This is not good for you, for your future. If you want to be a recognized researcher, if you want to have a stamp in your research area, then you need to be critical. You need to ask a lot of questions. And you need to get the answers for these questions. Okay? So research is not reporting. Research is not doing the same thing. You see this person do this research, and you just do like him. And then you see him how he interpret the result, just you follow his way. It's not like this. You need to understand. Okay? And you need to have your own way to understand and interpret. You need to be logical. You need to find or to give the right justification. When you try to publish in high impact factor journals, here you will find the difficulty if you are not critical from the beginning. Because those people, when they review the paper, they don't review it just, okay, this is, the drawings is very well, and okay, you write, the part of the work are there, and the results are enhanced, so it's okay. It's not like this. They go behind the result. They go, you see the figure, for example, and you see any different thing or something that they can grab their attention. And they ask, hey, why? What's happening? Can you interpret? Can you say? This is the research. Okay, so all these things are just anybody can do it. When you get your respondent responses, just give it to any technician to make a coding and to enter in the system and just to do some statistical analysis. Anyone can do it. But anyone will not be able to interpret it or understand why this is happening. Editing data, an example of an illogical response. Here it's about illogical response. Sometimes the respondents, they don't care about the questionnaire, okay, or about the question. Therefore, they can give some answers that are he will be biased, away of the meaning. So this one is called outlier. Outlier. Sometimes they call it anomaly. Outlier is the value that is very far from the normal should be. Sometimes they call it anomaly. شاذ بعيد outlier. كان شاذة لما تكون شاذة بالموجب أو تكون شاذة بالسالب بعيدة يعني. An outlier is an observation that is substantially different. See? Substantially. It is not how, somehow different. No, it is substantially different from the other observations. For example, if you are collecting data, and then, for example, for the temperature, for example, is 33, 32, 31, for example, 30, could be 34, 33, and suddenly you get 64. Outlier. If you take this value inside your sample or inside your data and try to analyze, the result will be biased toward the 64, because 64 will influence the result and everything will be wrong because it's not logical, it's illogical. Okay? So the first step is to exclude outliers from data. This is what they call it pre-processing of data. Pre-processing. One of the pre-processing steps, removing of outliers. Okay? So the other thing is inconsistent responses. Are responses that are not harmony with other information. This is when I told you sometimes they select this answer just by coincidence, or just taking agree, and then sometimes they reach negative question, and they take the same scale. So it will be inconsistent with other information.
It's not harmony.
Yeah, it's not in the same harmony. So you are not aware about what you are choosing. So you have to exclude this questionnaire or this respondent. So everything should be consistent. So inconsistent responses should be eliminated. Illegal codes are values that are not specified in the coding instructions. Sometimes through the coding, maybe some other codings which are illegible or not permitted. Illegible here means not permitted. Okay? For example, you are coding using integer numbers. There is some respondents is coded using negative, for example. Here, maybe we are using or we're supposed to use positive numbers. And sometimes, maybe by coincidence, by error, you just enter the minus, so it will change everything. So it should be remove illegible codes. Here are just some screenshots of transforming data, how you input the data and show it in the SPSS. Here just some statistical scale type data analysis and methods of obtaining a visual summary of variables, just getting a feel of the data, how to get summary of the data, statistical summary. In terms of, this is the type of scale, nominal, ordinal, interval, ratio, and here are just some examples. For example, in the ratio age and cells, for ordinal satisfaction rating, for nominal social security number, general, and what are the measures of central tendency, Here we use mode, median, arithmetic mean. I think we go through this one before. Measures relation between variables, visual summary, cluster, bars, how you draw them or you visualize them in terms of clusters or in terms of bars, okay? Or scatter plot, you know scatter plot.
Yes.
Drawing. So all these things are statistical characteristics of the data. Frequencies, how frequent this value in the respondent. Maybe you can get some information from the frequencies, or you can get some conclusions. But descriptive statistics, central tendencies, and dispersion also you can calculate, you can do it through the SPSS. It's just some screenshots. Reliability analysis, how to do it in SPSS. You need to take a course in SPSS.
No.
That's it.
You don't have to go into the